Amazon Simple Storage Service, or S3, is an object storage service that allows you to store any type of data. Now, anytime you create or update an object in S3, it raises event notifications. Your applications can listen to these notifications and perform additional business logics or application processing. For example, when a user uploads a profile picture, you can save this into S3 and listen to event notifications to process this in the background. You can convert it into different sizes as required by the application. We can also use event notifications to process large data files uploaded for bulk processing. These are only a few examples. In this video, let's learn about Amazon S3 notifications, how to set them up, and how to handle them from your applications. We will learn how to build and set up a Lambda function built using dotnet to listen to these S3 notifications. We will also explore the different configurations as part of these Lambda triggers and also learn about exceptions and how to handle them when processing event notifications. I will also show you additional integration patterns using SQS or SNS to handle event notifications. Hello everyone, my name is Rahul and welcome back to this YouTube channel. This video is sponsored by AWS and is part of the .NET on AWS series. You can check out the full playlist which will be linked here and in the descriptions below. Without much delay, let's get straight into learning more about Amazon S3 notifications and handling them with Lambda triggers. Here, I have my AWS console open and you can navigate to the S3 from recently visited if it's available, or you can use the search bar and search for S3 and navigate from there. I have an existing S3 storage bucket created, which is the name user contact data. Now, if you're completely new to Amazon S3, I highly recommend checking out my Getting Started video. Now, for this example, I will be using this S3 storage bucket and be attaching triggers for this. Once we navigate into an existing bucket, navigate to Properties, and scroll to the bottom of this, you can see we can set up event notifications. But right now, this S3 bucket doesn't have any event notifications. So let's click the Create Event Notification. This prompts you to enter a few details and also choose the type of notifications between Lambda, SNS, and SQS. Now, to set up a Lambda function as a trigger, we first need to build the Lambda function. You can also see the different event types that we can listen to when setting up the S3 trigger. To set our first trigger, let's first go and create a new Lambda function. I will be building this in .NET, so let's head over to Visual Studio and create a new Lambda function. So let's use the Create a New Project and select the AWS Lambda project using .NET Core and C#. Now this template is available because I have installed AWS Toolkit for Visual Studio. Now if you're completely new to building Lambda functions, I have a separate video which walks you through the entire process. So let's select the AWS Lambda project and click Next. Let's give this a name. So let's give User Contact Data Trigger. And let's choose the appropriate folder to save this in. And let's click Create. This creates a new Lambda function and it prompts us for selecting the blueprint. Now this is nothing but the startup code for this Lambda function. Now you can either start up with an empty function or you can choose the simple S3 function. This is a simple project which has already the code to react to S3 event notifications. Now since we exactly want that, let's choose the simple S3 function blueprint and click Finish. This sets up the new Lambda function for us. Here you can see we have the functions.cs, which is our function that is going to handle the S3 events. Now this already has some code set up, so let's walk through that. Now we create an Amazon S3 client inside the function constructor. It also provides an overloaded function constructor, which takes in an Amazon S3 client, which is mostly used for testing. The function handler is the main function code that will be invoked when our Lambda function is triggered. Now this takes in an S3 event, which basically represents an S3 event notification. So if you navigate into that, you can see the different properties that's available on the S3 event. Now this is the C# equivalent of the object that's going to be raised by the S3 when an object is created or updated, or anytime a notification occurs. Now this has a base class which is coming from S3 event notification, which has all the properties that we are interested in. Now we will be using some of these properties to interact with the object notifications that gets raised. So if we come back to our functions.cs, we can see all this does is it loops through the records inside the event. It expects only one record in this particular case, and it reads the S3 property on that event record. Now if the event is not null, it simply gets the object metadata and it returns the header type. In case of an exception, it simply logs and throws in this particular case. Now by default, since we selected the S3 template, we already have the NuGet packages that's required for this application. So if you look at the dependencies under packages, you can see that this already has the AWS Lambda.S3 events and also the AWS SDK.S3. Now the S3 events NuGet package is the one that has the S3 event class, and the SDK.S3 is used to get the S3 client, which is used to connect to Amazon S3. Now as you can see, when we create the S3 client, we do not use any credentials. This is because it's managed by the environment that it is running on. Now if you're completely new to credential management in AWS, I have a separate video that walks you through the scratch and explains the different options you have. Currently, the function handler is simply returning a string. Now since I don't intend to call this from an API endpoint, I do not want any return value. But let's simply log this into the console so that we can see this in CloudWatch. So let's use the context.logger and log the response.headers.content type, for example. And let's publish this into AWS. So let's build to make sure this is building fine. Now we can open the Solution Explorer, right-click on the project and use Publish to AWS Lambda. Now this again is available because I've installed AWS Toolkit. Now this is already connected using credentials to my AWS account. Now let's give this function a name. So let's use the same user contact data trigger as the name for our function. And this is wired up to the appropriate handler. So let's click Next. And let's select a role name for our Lambda function. In this case, all we need is the basic Lambda execution role. So let's select the AWS Lambda basic execution role, which provides write permissions to CloudWatch logs. And let's click Upload. This uploads the Lambda function that we have just written into my AWS account. The Lambda function is successfully published. So let's navigate back into our AWS console. Let's open this in a new tab. And let's navigate to Lambda functions. Now this has all the Lambda functions inside my account, and we can also see the function that we just deployed, which is the user contact data trigger. So if we navigate into that, you can see the full details for this Lambda function. Now a Lambda function can be triggered using different triggers. One of this is the S3 trigger, which is what we will be using in this particular video. To set up the Lambda trigger, you can either create this under the event notification by selecting the Lambda function, or you can also set up from the Lambda page itself. Now to set up from the Lambda page, just navigate to Configuration, go under Triggers and select Add a Trigger. In this case, we can select the source as S3 and we can select the bucket that we are interested in. In this particular case, it is the user contact data bucket. Now you can also specify the event types, which is the different event types that is available. So in this example, let's use the all object create events, which is put, post, copy, and also multi-part uploads. So let's select that. Let's leave the next two options as empty. This also shows a message on recursive invocation, which is to ensure that you're using different S3 buckets for input and output. We will see about this a bit later in this video. So let's acknowledge this and let's click Add. We have successfully set up an S3 trigger for this Lambda function. So if we navigate back to our S3 bucket and if we cancel this and refresh this page, you can see under the properties, we also have a new event notification set up here. So these are just two different ways to create the same event notifications. Now if you select this and edit this, you can see the different properties that's automatically set up. Under the event types, it's set to the all object create events. You can also scroll down and you can see that this is a Lambda function and the Lambda function details. Now anytime a new object is going to be uploaded into our S3, so let's navigate to objects, this is going to raise an event notification, which will trigger this Lambda function. Now if we come back to our Lambda function, you can see that on an S3 event, it reaches back to get the object's metadata from the S3 itself. This means the Lambda function also needs permission to talk to the S3 object. So let's set this up first before we upload an object. So let's navigate into the Lambda function and go to the permissions section and select this execution role. This is the execution role that was automatically created when we uploaded the Lambda function from Visual Studio. Now you can see the current permissions is the basic Lambda execution role, which gave it permission to write to CloudWatch. Let's also add the permissions and create an inline policy. And we'll set up access to the S3 itself. So let's choose a service, select S3, and let's select the actions that we need. In this particular case, let's simply give the get object action. Now this is all that it requires to read the object metadata and also the object itself. So let's specify the ARN. So to restrict the access to just the user contact data, let's specify the bucket name here. So this is the user contact data. And let's give access to any object inside this bucket. So this will give access for this Lambda function to get any object from this bucket. So let's click add, let's click review policy and give this a name. So let's name this as user contact data S3 policy. And let's click create policy. Now this gives it permissions to talk back to our S3 and get object details from that. So once that is set up, let's come back here and ensure these permissions are set up correctly. So if you refresh this Lambda function, you can see all the permissions that this Lambda function has in the resource summary. So you can see this has the CloudWatch logs and also access to S3, which is just this specific bucket and any objects inside that. Now once that is all set up, let's navigate to our S3 and upload our first object. So let's go into the objects section. I already have a few JSON files created, so let's drag and drop one of them in here and click upload. This uploads this JSON file into this S3 bucket, which will have raised an event. So if we come back to our Lambda function, go to monitor and see the logs in CloudWatch, and here we can see the CloudWatch logs for this Lambda function. You can see that we already have a log stream automatically created. So let's navigate into that. And you can see the logs from our Lambda function. So you can see this is of type application/JSON as logged from our function statement. So we simply got the object metadata and logged the content type from the header. So now we have successfully set up an S3 event trigger to the Lambda function that we built. Now currently, the function is simply getting the object metadata, but you can also additionally read these files and use this for application processing. Now for example, we can come here and update this code. So let's say var file is equal to await this.s3 client, and let's use the get object async method to get the file itself. Now we can give the s3 event.bucket.name and also the s3 event.object.key. So this is the bucket name and the key, which is basically the file name. So once we have the file, we can use a reader. So let's specify using var reader is equal to new stream reader, and let's pass it the file response stream. So this is the file.response stream. So this reads from this stream. Now we can read the file contents. So Visual Studio is automatically suggesting this. So let's say tab. Now it uses the reader and reads to the end as an async and gets the JSON content from this file. Now we can rename this to simply say file contents. Now if we want to log this, let's remove this logging and simply log the file contents. Now this function is connecting back to the S3, getting the actual object and reading the file contents and logging that. Now in your application, you can use the file contents to process the business logics or for additional application processing. So let's publish this and see this in action. So let's right click and say publish to AWS Lambda. We have all the details already set up. So let's simply click upload. Now since we had already set up the policies to read the object, we don't need to set up the Lambda function with additional policies. So let's come back to AWS console. Let's go to the management console. Let's close this and upload this file again. So let's simply drag and drop this file. Now since the same file name exists, this will overwrite this file in S3. So let's click upload. So let's come back to CloudWatch. Let's navigate back to the log stream and let's refresh this. Now this has created a new log stream because we published a new instance of the Lambda function. So let's click this and we can see the JSON information that's in the file. So you can see there is the ID, the name, the address, and the email. So if I open up this rahul.json locally, you can see it is having the same contents. Now when we uploaded this, it raised the S3 event notification, which our Lambda function read and retrieved back this file inside the Lambda function and use it for its own processing. With the current setup, if you upload a file to anywhere in the S3, it will raise an object notification. Now if you want to filter for specific files, let's say you have a hierarchy inside your bucket and you want to be notified for only files in specific folders or with ending with certain file types. You can do that by applying filters on the S3 trigger configuration. So let's navigate back to our Lambda function. Let's go into configuration and under triggers, let's edit this trigger. So let's select this and click edit. Now this gives you an option to set up a prefix or a suffix. Now if you want the processing to be limited to specific folders, you can use the prefix, or if you want to restrict the processing to specific file types, you can use the suffix and enter a file extension. Now in this particular case, let's give this a prefix. So let's say unprocessed, which will be the folder name inside the S3 bucket. So let's specify that as the prefix and click save. Now this updates the Lambda trigger configuration. So if we come back to our CloudWatch, let's navigate back. Let's delete all these existing log streams so we know clearly what's happening. So if we come into the S3 bucket and upload this file again onto the root of this S3 bucket, the object notification that's triggered by this upload will be filtered at the Lambda level because we have updated this configuration. So if we come back to the CloudWatch and refresh this, we don't see any log streams being created. This is because our Lambda function is not getting invoked at all. Now if I come back to S3, let's close this. Let's create a new folder inside this. So let's use the same name, which is unprocessed, and let's create the folder. Now the folder concept is simply a hierarchical concept in S3, which is simply by naming a file with a slash at the end. I walked through about this in my S3 introduction video. Do check that out in case you haven't already. So now if you navigate into the unprocessed folder and let's upload another file. So let's upload the test.json and let's click upload. Now in this case, when the event notification is triggered, this is under the unprocessed folder, which means our Lambda function's filter will accept this event through and it will get processed. So if we refresh this again, you can see a new Lambda stream record. So if we navigate into that, you can see this is processing this file as expected. So you can see the same contents inside the test.json. So if we open the test.json in Visual Studio Code, you can see all the contents inside there. Similarly, you can also update the trigger to specify the suffix if that is what you want. You can update these trigger properties either on the Lambda side or on the S3 side, which is basically the same object. So if we navigate back to user contact, properties, and if you navigate under the event notifications and edit this, you can see this would also have the prefix that we currently set at the Lambda configuration. Now both these UI is looking at the same configuration. Now in cases where your Lambda function needs to write back to the same S3 object, you can prevent recursion by using these prefix and suffix. Now in this particular case, since the Lambda function is triggered only when files are changed into the unprocessed folder, you can make sure that our Lambda function does not write back to this folder. So if you want to process this, you can put a new processed folder and write the processed contents into that folder. So that would not trigger the same Lambda, which avoids the Lambda function being recursively called. Now whenever an S3 event notification happens, it calls the Lambda function asynchronously. This means it simply notifies the Lambda and does not wait for a response. So when an S3 event notification happens, it simply passes on that to the Lambda and it returns back. So you can see in this diagram how Lambda handles asynchronous invocations. So whoever is raising these events simply puts this into an event queue, which is for that Lambda function, and simply returns back. Now the Lambda processes these functions from the event queue in an asynchronous manner. So based on your concurrency settings and the number of messages that arrives in this queue, you will have multiple Lambda functions handling these messages and processing them in the background. Now, the asynchronous processing works fine until we have an exception inside our Lambda function. So let's see what happens when an exception gets thrown when we are processing an S3 event notification. So let's navigate back to our function code and let's simulate an exception in the processing. Now, in a real-world Lambda function, this could be because of various reasons, including unhandled code scenarios or external dependencies that might not be responding as you expect. But for now, let's simply mock and create an exception. So in our case, let's simply check the S3 event, the object key. So let's use the S3 event.object.key. And if this contains the word exception, we will throw a new exception. So let's check for this and let's say throw new exception. And let's say exception processing file. And we can also give the file name if we want. So let's use string interpolation. And let's pass in the file name in here. So let's use the S3 event.object.key inside this. So whenever the file name that we upload contains the word exception, it is going to throw an exception. So let's build this and let's publish this to our AWS account. So let's use publish and simply say upload because everything is already set up. Now we have successfully uploaded the Lambda function. So let's navigate back. Let's come to CloudWatch and let's navigate to the S3 bucket. And let's upload a new file. So let's go into the user contact data. Now we have the filter so that it processes only the files inside the unprocessed folder. So let's update it into this folder. So I have a file which says sample exception. So let's drag and drop that in here and click upload. Now this triggers the event notification, and since it's inside the unprocessed folder, the Lambda function will be triggered. So let's refresh this. And we see a new stream record. So let's navigate into that and we see the exception that is getting raised. So it says error processing the file and it gives the full file name. Now whenever an exception happens, the default behavior in case of an asynchronous invocation is to retry this. Now the Lambda attempts to retry it 2 more times by default. And there is a certain delay between these retries. Now the first retry will be after 1 minute. And after that, the second retry will be after 2 minutes. So we'll have to wait for 3 minutes to see these 2 retries inside our logs. So if we come back to CloudWatch and refresh this again, you can see the function has been called once more. Now in this case, you can see the exception processing the file and the exception message again because the file name is not changing for this event and our exception is based on the file name. In a real world, if you were depending on a third-party service which was intermittently down, this retry could have passed through. But for certain exceptions which does not fix with retries, it will error out at the end after 2 retries. So let's see the event timings. You can see that the first error message happened at 5:19. And after that 1 minute, it again got reprocessed at 5:20. Once 2 minutes is passed after this first retry, it will again invoke this Lambda function. So after 2 minutes, if you refresh this logs again, you can see that the Lambda function is invoked once more. So you can see the exception processing again, and this time it's at 5:22, which is 2 minutes after 5:20. That is the first retry. So now the Lambda function has done a complete of 2 retries and it will give up on this message. But in some cases, you might want to hold on to this message so that you can take action on it later. So maybe you have an external dependency which was down for more than this 3-minute period and you want to reprocess these messages later again. The retry behavior for the asynchronous invocation can be controlled under the Lambda configurations. So if you navigate back to the Lambda, and go to asynchronous invocation, you can see the settings for that. Now if we edit this, you can see the default retry attempts is set to 2. This is why the Lambda function just retries 2 times. Now this is the maximum value that you can set, so you cannot set more than 2. However, you can set up a dead letter queue service so that you can set up a queue or an SNS topic to send these errored messages after the retry. So if after 2 retries, if you're not able to process this, you can move this into an SQS or an SNS service. You can also configure the maximum age of the event, which is 6 hours by default. So let's set up an SQS queue as the dead letter queue for these error messages. So let's select SQS and let's select a queue. Now I already have a queue created, so let's select that, which is the user-data changes, and let's also update the retry items to be 1. So after one retry, it will immediately move this message into this particular error queue. Now before saving this, we need to ensure that this Lambda function has access to send the message to this queue. Now if you were to click save right now, this is going to say an error message, which says you do not have permissions to call send message on this SQS. So let's come back to our IAM console where we added the S3 policy, and let's click add permissions and create a new inline policy. In this case, we need to select SQS because that is where we are trying to give the permissions for. So let's select SQS and let's select the right action and say send message because this is the permission that the Lambda function needs to send a message to this SQS. So let's also specify the error queue ARN. So let's say add ARN. Now if we navigate back into our AWS console, let's open this in a new tab. Let's navigate to simple queue service and let's navigate to the user data changes queue. Let's copy the ARN from here and use this in the IAM ARN policy. So let's paste this in here and click add. Now this gives access to send message to this specific queue. Let's click review policy and let's give this a name. So let's say user data changes SQS policy and click create policy. Now this gives permissions for the Lambda function to send message to the queue. So if we come back to the configurations and if you click save again, this time it's going to create and update the configuration. So now you can see the asynchronous invocation is set to a dead letter queue. Now to test this, let's navigate back to our CloudWatch. Let's delete all existing logs so that we can clearly see what's happening. And let's come to our management console and upload this file again. So let's drag and drop the sample exception under the unprocessed folder. Now this triggers the event notification, which triggers our Lambda function, and let's see the log events. Now a new log stream is created. So let's navigate to that. And this time it triggers the exception as expected because the file name has the word exception. This is going to wait for 1 minute for the retry. Now after 1 minute, if we refresh this, we can see that it has retried again. So you can see the second time exception processing the file. Now since we had set up the retry count as 1 and after the first retry it's still failed, it would have moved this message into the SQS. So if we navigate to the SQS and navigate to send and receive messages and let's poll for messages, you can see that we already have a message inside here. So if we click that and expand this, we can see the details of the S3 event. In this particular case, you can see that this is the key, which is the unprocessed sample exception.json file. As you can see, the S3 event notifications is not completely lost and it's still available for us to process at a later point. Based on your application and business scenarios, you can choose when and how to reprocess these messages. You can also use message triggers on this SQS to process the messages. Now, if you're completely new to Amazon SQS, I highly recommend checking out my Getting Started video on that, which allows you to process these messages as well. When we set up the S3 event notifications, we saw that there are other destinations also available. So if we come under event notifications and click create event notification, we saw that at the destination type, there is also an option to set up an SQS or an SNS. In these cases, you can directly send S3 notifications to one of these. So instead of directly handing it over to a Lambda function, you can publish the S3 event notifications to an SQS queue or to an SNS topic. This allows us to decouple and have more control on the notifications from the S3. So if you have multiple subscribers that's interested in the same file notifications, you can use an SNS topic and publish these notifications to SNS and have different subscribers there. You can also publish these messages directly to an SQS queue and avoid having to set up error queues for the Lambda function just like we set up now. So you can have one process to process all the messages based on an SQS event. Now you can again use Lambda triggers to process from SQS, which I walked through in a separate video. Let's see an example on how we can integrate with an SQS queue. So let's come back and let's give this event a name. So let's call this as user contact data notifications. Let's leave this as blank. let's select all object create events and let's select an SQS queue. And let's choose the same SQS queue that we used for the error configurations for Lambda. And let's click Save Changes. Now in this case, it currently throws an error because there is an ambiguous configuration defined. It has noticed there is an overlapping suffix in the two rules. Now since we already have a Lambda trigger that's listening to for file changes in the unprocessed folder, we cannot listen to events at the root folder because that will include all the events that's including the unprocessed folder. So we'll have to specify another prefix. So let's say processed in this particular case. So we'll create a new processed folder and just listen to events on that folder. So let's come back again and let's click Save Changes again. Now this again returns an error because the S3 bucket does not have permissions to send to the SQS queue. So right now, for any notifications, it is trying to send the message to the SQS. However, we haven't set up the SQS with the appropriate permissions. So let's navigate to the SQS. Let's go into the access policy under the SQS and let's edit this access policy permission. So let's click the edit button and you can create the policy statement inside here. Now to help with the policy generation, you can use the policy generator which is attached in here. Now I have it already created, so let me copy and paste and walk you through the policy. Now this simply adds a new example statement, so we can give this a valid name in this case. So we can specify that user data changes S3-SID, or you can use a random GUID if you prefer that. Now this is giving an allow access for the principal which is s3amazon.com. Now this gives the SQS permission to send the message, which is the same that we set up for the Lambda function, and it specifies the resource. In this case, we need to give a valid queue name that this is applicable to, which is the same queue that we are trying to write this into, which is the user data changes. So let's copy that and specify that name in here. So this is the resource that this policy is applicable for, and we have a condition that the ARN of the S3 bucket should match this source ARN. Now the bucket name is user contact data. So let's remove this bucket name and specify the name. So let's specify user-contact-data. So the source account is my Amazon account ID. Now once we have given this permission to send the message for the Amazon S3, which comes from just this bucket name, and it can send messages to this queue. So once that is set up, let's scroll down and click Save, which saves this policy. Now if we come back to the S3 bucket and click Save Changes again, this time since we have the appropriate policies, the event notification is set up successfully. So you can see two event notifications. One is for our Lambda function and the other one that we just set up for the SQS. Now if we come back to the objects, let's create a new folder here. Let's call this as processed and click Create Folder. Now this creates a new folder which is processed. So let's navigate into that and let's upload a new file. So let's say rahul.json and let's click Upload. Now when this event notification is going to happen, since this is in the processed folder, it is going to move this into the SQS. So let's navigate to the SQS. Let's go to Send and Receive Messages and let's click Poll for Messages. So here you can see multiple events already coming into our queue. So if we navigate to one of them, this one was a test event that was set up when we created the notification. So let's go to the next one and you can see this one is for the processed rahul.json file. You can also see the other ones which happened when we created the new processed folder. So for all these events, we are getting the messages into our SQS queue directly. Now if you have set up a Lambda trigger on this queue, you can start processing these messages in the background just like our Lambda function before. Now if you have multiple subscribers that's interested for these events, instead of setting up an SQS, you would be setting an SNS, which is a simple notification service. But the process of setting it up is still the same. I hope this helps you to understand more about S3 event notifications and how to use them in your applications. We learned how to set up an S3 event notification, how to listen to it using Lambda functions, how to set up filters and additional configurations, and also handle exceptions. We learned how to set up the error queue to handle messages that have been errored and cannot be processed any further. We also saw an example of direct integration with SQS where you can directly send messages to SQS anytime a S3 event notification happens. If you like this video, please make sure to hit the like button. If you want to be notified of future such videos, make sure to hit the subscribe button. It also helps me to grow this YouTube channel. Thank you and see you soon in the next video.